Hello, so we're doing the final Fluent project with wind tunnel simulation. I'm going to open up in the design modeler as 2D. And then we're going to start sketching some lines in order to make our wind tunnel. So here we started. I had already started. We're in dimensions. With these horizontal dimensions. This line. We'll come out, we have 1, 2, 3. We'll just put in our dimension. These are, let's see. Oops. These are these lengths. H1 should be 0.1176 meters. H2 being 12192. And H3 being 1.5748. That'll let that happen. And then we're going to sketch more lines. One more across these. And then we're going to do a constraint, a midpoint constraint on that last one. If it had generated. Yeah, there we go. Midpoint to this origin. Hold on. Let's see what constraints we have. And once that's done, then we can start with finishing the sketch. So then we're going to create a couple of vertical lines. Oops. A couple of vertical lines. And then move these to their spots with the midpoint function. Okay, and then we're going to finish drawing these lines. Well, actually, we're going to dimension these heights. And then these will be according to the work of according to the document 6096. This one will be the same. And then this one will be 0.889. And then we're going to finish this by finishing the drawing, closing off everything. And then that should basically be most of it. Then we just get to delete a couple of lines, everything that we don't need. I'm gonna just fix my select button. We can delete these lines. And then that should basically be it. I wonder if I can move this. No, that's alright. And then there we should have basically what we need. Go to modeling, go to click on this sketch, go to concept, surface sketches, apply, and then generate. And then here we have wind tunnel. Now what we can do is go back to here and then create the mesh. well, we can update the geometry just in case, and then work on the mesh. Now that we have our mesh pulled up, or yep, so we're gonna start working on it. We're gonna insert a method. We're gonna select this surface, and we're gonna make it triangles. We can generate this, and we're gonna go back to mesh, and then we're gonna make element size this number. It's okay. And then we're gonna add a. Actually, that might be a quick generate. Might take a minute. And then here we have our mesh, and then what we can also do is start naming the edges and the surfaces. These will be named outer wall, and this edge will be named velocity inlet, and then here outlet. And that should be it for this one. Generate, then we can go back to we can go back and update this and start working on the setup. We are going to use double precision and start. And then here, what we can start working on is set it up. So we're going to change the model to K epsilon. We're going to allow enhanced wall treatment and pressure gradient effects. Click OK. And then make sure that our materials are correct. Yep, here we go. Then we're going to mess with the boundary conditions. At the inlet, we're going to make a velocity of, we want the inside of the actual wind tunnel to have an average velocity of, free velocity of 15 meters per second. Using the contraction ratio, we are able to get that the velocity here, this inlet, should be this number in order to have that 15 meters per second velocity there. So apply this, close, and then make sure that our outlet is a pressure outlet. Yep. And that our walls are not moving and have a no slip condition. Correct. And then here we can just run in simulation to 200 iterations, run, initialize, and calculate. And this will take a while. Now it has finished iterating in order to get some of the requirements that we have. Need all of the different contours, which we can just go right about into the results, go to contours, and then make them all. Here, if we wanted just the pressure one, save and display. This is how they would look. If we wanted the total, save and display. Looks just like this. If we wanted the dynamic pressure, save and display. Looks just like this. And then if we wanted the velocity, it would look just like this. And what else did we need? We needed, yep, all 3 or 4 of those things. Center line, and we wanted about the variations. Yep, okay. So in order to do these, we can go to the plots. We're going to do an XY plot. And then we're going to make a new surface here with a line. We're going to make a line. And so we know that the length of this, we're going to put in the length of this to get our center line, and then keeping our Y 0, and then we'll make a vertical line as well. So here the length of that is around 3.911, I believe. So new surface. Don't know why this is not responding. But yeah, we can go to the new surface, make a line, and then put in our profit length. So this would be around negative 1.955 to 1.955. This will be the center line. We create this. Actually, we might be able to. Yep. Then we'll make our another line. This will be the vertical line. And here we just need the diameter of that inner wind tunnel. Here this will be 304, negative actually. And then this will be 0.304. Create this, close, now we have our line. So now when we want any of the different questions at those points. So along center line we want the pressure, velocity, total pressure, and dynamic pressure. So here we're going to do pressure, that center line, save and plot. Here we find that. When we want the dynamic pressure, here we have that. And then when we want the total pressure, this is what that kind of looks like. This one's a bit odd. And then for the velocity, here we have that. And then we can do the same with the distributions of the vertical wall. We're going to unselect these. And then here it wants us to put in the velocity, dynamic pressure, and total pressure. So here, in order to plot this will be different. We have to put here 0 and 1. And click this to be on the y-axis. And here we can put the velocity, save and plot. That's how it looks. And then the dynamic pressure, split like that. And then the total pressure. Kind of looks like that. And so that is kind of about, actually we need the streamline patterns. Here we would just go to our results and then plot it there.